Reginasailing family and friends. Let's see how far we have come in our twilight calculations. So this is what we have done before. So we have 26th of February, we have a morning position and an evening position here in red, and we have calculated the time of twilight first at the meridian. Then we use time to arc to find the civil twilight at our position in the morning and in the evening. This is very important and it's very easily done. Then we looked at which planets we want to be looking at, and we chose Jupiter for the morning and Venus for the evening. Now, do we have to do all these calculations, which maybe felt a bit over the edge for a planning? Well, in this respect, at this time, yes, I think, because here we can see how nicely we can calculate a altitude, pre-calculated altitude, which you should see in a certain direction. Now, after some time, and especially if you now have gotten to know the first point of Aries, this wonderful point in the sky, you can get a sort of feel for all this. Because the most important thing is here that the Jupiter is 3 hours ahead and the Venus is 3 hours behind. Because that is already giving a lot of information. And this is so important that when planning the shots, you can either find this here as we did it, on this beautiful page there. And the other place you can find it is actually on the daily pages. So if we open this page here for the 26th of February and we look on the star and planet side, you will see that on the very bottom page there, here, you can see that the Venus has a side hour angle and a meridian passage of 3 o'clock. That means that the Venus is 3 hours behind the Sun, because the Sun has its meridian passage at around 12. If you want to know it more precisely, you can look on this side. So the meridian passage is 12:13 actually. So Venus is a little bit more than 3 hours behind. And Jupiter, it has its meridian passage at 9 o'clock. So Jupiter is 3 hours before. So also on the daily pages you get exactly this piece of information, how much before and after the corresponding planets are. And when you have some feel for how the planets look like, it will be very easy to judge these 3 hours. Because, if I may draw it here, let's look at the evening. Here's the horizon. There's the water. So at sunset, so here we draw the sun. We still have the, in this case, the Venus up here, because it's behind. First the sun sets and then the Venus comes thereafter. And in between here we said that there are about 3 hours, and that corresponds because every hour is approximately 15 degrees, so that's 45 degrees, very approximate, because it also depends on the angle, of course, and if they are both in line and vertical or if they are a little bit tilted. So we don't want to shoot the Venus at this point in time because it's too bright. So we have to wait until the sun has set. It's behind the horizon. And by that time, Venus has come a bit further down as well. That's here. So, of course, still the difference between them is approximately 45 degrees. And the height here is because we wait about half an hour after sunset. So the sunset is 1843, so we do it at 19:09. So that's about, well, roughly half an hour. Take it or leave it. So this is 2.5 hours. So the height above the horizon is worth about 2.5 hours. Very, very roughly. So with 15 degrees, I would expect this to be for 2 hours is 30 degrees. So it's a bit more than 30 degrees, maybe 37 degrees. And so what you do is you look where the sun has set, and then you look up above in the sky, about 37 degrees up, And the biggest thing there you could see should be the Venus. Now at sunrise we have the same thing. So at sunrise we have the sun here, and we have the Jupiter here. That's the Jupiter. So the in between these two, it's 3 hours. By coincidence, they're both 3 hours. One is ahead, one is running behind. But in this case, it is both 3 hours, 45 degrees approximately. But this is too late because in the morning, the sun would be too bright to shoot the Jupiter. So we have to do it a little bit earlier. So about here at twilight. So the sun is still behind the horizon. And this is where the Jupiter is. So this would be the time to shoot the Jupiter. Now these are also 3 hours, so 45 degrees approximately running ahead. So this is the altitude between the horizon here, and that I can't really see how much it is, but it must be at least less than 2.5 hours worth of it. So it should be less than 37 degrees because they're not quite in line here. So let's say some less than 30 degrees approximately. So what you do is that you look in easterly direction and expect where the sun should be rising. You could see a little morning, maybe the nice orange light coming up there, or you take the hand-bearing compass, and in the reeds you can actually see in which direction the sun is rising depending on your latitude. That is something that we will look at the compass check chapter. And then you judge somewhere about here, and when you see some bright thing in the sky some 30 degrees above the horizon, that should be the Jupiter. And if we compare this thinking here, it doesn't really fit, but approximately at least. So we said here that the Venus we should have some 37 degrees there, and we have actually 36 degrees and 47 minutes it should say here, above the horizon. And for the Jupiter here we have some roughly 20 degrees, so it's less than 30. I would have expected this to be a bit higher, but this is what the calculations gave. But this is approximately what you can have as an eyeball sight. So you don't have to do all these calculations if you can recognize Jupiter and Venus in the evening and Jupiter in the morning on this day. It's all dependent on the day. But if you do it tomorrow night, it will be very similar like this. And the day after, again, very similar. And that is something that I always think is a bit extra difficult when you do celestial courses, because you're moved around the planet in the exercises. You are on southern latitude, the northern latitudes, on the other side of the world, all sorts of things. But in real life, what you do in one day will be very, very similar to the day after. So this is now how far we have come. We will now look at the Aries, the first point of Aries, because most probably you've done the stars course, my video on stars. So we look at Aries, and you will see how much easier it is to work with Aries, because it has no declination and it's the one single spot in the sky where all the other stars are related to. And then we can also use the Jupiter in relationship and Venus in relationship to Venus. That's really good. So let's look at the side, our daily pages here on this day, on the 26th of February. And here, the first column, because it's so important. On this side, the most important thing is the sun. On this side, Aries is so important. And here you have the 4 planets that you usually use. And what is maybe interesting to see is that you have these negative or positive figures behind the planets. And that is how bright they are in the sky. For reasons I cannot explain, is that the more negative it is, the brighter it is. So Venus has minus 4.3, it's very, very bright. Jupiter has minus 2, so that's second brightest. And that differs from day to day as well, how bright they are. And Mars is really bad these days, 1.2 positive and Saturn 0.7. So if you look on some very other day, you can see that the number of Venus and Mars and Jupiter are different. But today we can see how bright they are. So we have Aries and the planets, and here are the stars. So we have loads of stars, 58 navigatable stars, and the side hour angle and the declination. Now these you have to add to the Greenwich hour angle of Aries. So on the 24th here at 00 o'clock, we have a Greenwich hour angle of 153 degrees and 20.6 minutes. That's where Aries is. And the more the hours go, the more Aries moves. Well, the Earth turns and Aries is where it is. But nevertheless, it looks as if it turns above us on the celestial sphere. And the star, if you take the Akamar here, the first star, there you have to add the 315 degrees side hour angle to the Greenwich hour angle. And these are always the same, because in these stars, in respect to Aries, will always remain the same. So 315 degrees and 14.9 you would find on any other day. 315 degrees, 14 point, well, a couple of minutes there. Why this is different? Well, I don't know. Maybe because the side hour angle is different. Yes, it is. It's a bit different. Nevertheless, the side hour angle has to be added to the Greenwich hour angle in order to get the real Greenwich hour angle for this corresponding star. Same with declination. You take 40 degrees south here and 13.9 minutes south. This declination of this star is in respect to Aries. Now Aries doesn't have a declination because it's always above the equator. Very practical. So this is the final declination. So once you have done calculated what Greenwich hour angle the star is that you want to be using in respect to Greenwich hour angle, and added the side hour angle and use the declination, you can use the same template as I have for the planets. The only problem is here that you will see that there are some declinations which are really big. So if we zoom it in again, or I lift the book, you can see here this is a declination of 55 and 49 degrees. But our tables, our air navigation tables, only have a declination up to 30 degrees. So any star that has a bigger declination of 30 degrees you cannot use. So that's the difference between the aeronautical side reduction table and the nautical side reduction tables, because the nautical side reduction tables go all the way for a declination of about almost 90 degrees. This is, so as I said in the introduction, this is the old school, because it makes it all very complicated, and you don't know which star you should be looking at in the sky anyway, and where are they. So you have to have the star finder to find them. We'll look into that after we have looked at this method without the star finder. And then you do a lot of calculations. It's much easier to use the side reduction table volume 1, where they have already pre-calculated which stars we want to be looking at. So what we do here now is that we, for the morning and the evening, we say where the point of Aries is approximately. It's very easy because you only have to do it roughly. So we're looking at 7 o'clock. So at 7 o'clock in the morning, what's the declination of Aries? Well, it's always 0. So that's why I have pre-printed 0. So don't fall into the trap to look up a declination for Aries. Then we want to have the Greenwich hour angle of full hour. So again, if we zoom in here for the full hour, I first do it the exact way. For the full hour, we have a Greenwich hour angle of 245 degrees and 33 minutes for Aries. So if we do it really precisely, for the full hour we have 245 degrees and 33 minutes. You have the increments for these 58 minutes. So you do the increments of the 58 minutes, and that is 14 degrees and 30 minutes. 14 degrees and 30 minutes. You add these two together, so that makes it 260 degrees. So that would have been very easy just to check in the beginning as well, because it's approximately 7 o'clock. So look at here. No, not there at all. So it's approximately 7 o'clock. So if you look here at 7 o'clock, where is it? There, it says 260 degrees, 36 minutes. So 260 degrees, that's good enough as the Greenwich hour angle. And now we will do it very approximate for 1909. The Aries has no declination. And now let's look what the Greenwich hour angle is at 19 o'clock. Aries, we go down here on the 26th. We have at 19 o'clock 81 degrees and 5.7 minutes. Well, call it 81 degrees, that's good enough. So I'll write 81 degrees here. 81 degrees. Then we need the increment for the 9 minutes. So we'll take 9 minutes here. We have 9 minutes there. Any seconds? We look at the second column here, Aries. You see that they're very similar, sun planets and Aries, because it has mainly to do with the Earth turning around itself. So 9 minutes flat is 2 degrees and 15 minutes. Well, call it 2 degrees. 2 degrees. We add these together to get the Greenwich hour angle, so that's 83 degrees. Our own longitude is around 13 degrees in the evening, so that's 13 degrees. So the local hour angle is, when you deduct these two, because we are western longitude, so we just deduct these two, so that becomes 0, and this becomes 70. So we have a Greenwich hour angle of a local hour angle of 70 degrees. And in the morning we do the same thing here. We have our chosen longitude, it's about 11:56. Well, we can call it about 12. So we deduct these two, and it begets a local hour angle of 248. 248. So we have two local hour angles. We have 248 degrees in the morning, and then the local hour angle of Aries is 70 in the evening. Now let me show you how fantastic the sight reduction table volume 1 is, because it has all to do with Aries and it gives us all the stars. So in the morning we know that Aries is positioned 248 degrees in relationship to us, has a local hour angle of 248, and in the evening of 70 degrees. In the morning we have a latitude of about 37 degrees. So we look at the star volume, the volume number 1 of the sight reduction table, look up our latitude, and then here it says local hour angle of Aries. So the local hour angles is 248 degrees. So we go down here and we find here 248 degrees. So that is our latitude. So that is our local hour angle of Aries. Sorry. So when we have a local hour angle of Aries, it suggests us to use one of these or several of these 7 selected stars. So we have here some with capital letters, they are especially bright, and a diamond, they are especially useful. So the best thing is to have a useful star which is bright. So Deneb is perfect, Antares is perfect, Antares. Oh, did you know that Antares makes great charts in Scotland? And then we could use, well, whatever we want to use. We could use maybe the, I think we go for the Arcturus, because even though it is not so useful because of the angles, it's very bright, so we want to have bright stars. So let's take these 3. So for instance, the Deneb at 248, it gives us an HC of 43.24 and an azimuth of 0.59 degrees. And the same here on Antares. It gives us 26 degrees and 32 minutes on the sextant, and an azimuth due south of 180 degrees, an Arcturus 55 degrees and 26 minutes, and a azimuth of 248. So let's take those. And that's why I have prepared my template here to write here the stars. So the morning stars for the local hour angle of 248. One star is Deneb. The next star is Antares. And the third star is Arcturus. So, never mind their names really, but they are beautiful. So we'll write down the HC here, 43 degrees 24 minutes, and the azimuth, which is 059 degrees. For Antares, we have here, I said it before, 26 degrees and 32 minutes on the sextant, due south, and Arcturus has 55 degrees, 26 minutes, and an azimuth of 248 degrees approximately. So in the morning, we use our hand-bearing compass, look into these three directions with the preset altitudes of these, and there these stars should be on the horizon, so we can shoot them more precisely. And that is the whole shooting procedure. It comes later. This is still all planning. So let's plan here in the evening. So in the evening we actually have another latitude. So in the evening we have a latitude of about 35 degrees. Very often you don't have another latitude. I just do it for the sake of the exercise, so you don't forget that you should look into the right latitude. Take the corresponding local hour angle of 70 degrees. So let's go down there, 70 degrees. So we have a couple of stars here. So which one do we take? Well, we take a big fat one here with capital letters, the Sirius, maybe. Shall we take the Pollux also? That's a bright one. Maybe one here, Hummel. So let's choose Hummel and Sirius and Pollux. So I write these down here. Pollux and with 70 degrees, Pollux, and I chose Sirius. Sirius make great boats. Sirius, and then we take Hummel. Hummel, if we want to. You can choose anyone. You could choose them all actually. So the Pollux I just read off here. 49 degrees and 59 minutes, and the azimuth is 087 degrees. The Sirius has an angle of 30 degrees and 14 minutes on the sextant with an azimuth of 145 degrees, and the Hummel has 55 degrees 14 minutes on the sextant with an azimuth of 261 degrees. So here's all the preparation. What you could do is also follow this, what says here down below there. It says right time of twilight next to the LHA of twilight in the volume. And then for each local hour angle before that and after that, 4 minutes earlier or later. What does that mean? Well, that means that we can use this. Well, this is the 37 we have here in the morning. Here the 37. I'll make the example on this page. So the best time is 6:58. Then we have an local hour angle of Aries of 248. So this here is valid at 6:58, this angle. Now each degree before that means 4 minutes earlier, because 4 minutes it takes for the Earth to turn 1 degree. So when it says 247 there, we'll write 4 minutes before that, and that is 54. And with a local hour angle of 246, that's 1 degree less, we can say 650. And the same thing, 249, we take 4 minutes later, and 250, it is yet 4 minutes later. So if you look at that more precisely, there you can see that. So there I wrote these. I hope you could see me writing there. So that means that when you start shooting at 650, you will have a local hour angle of 246, and you can exactly see here and read off what the altitudes should be and the corresponding azimuths. 4 minutes later, you jump one line, so you are in 247 here, and you have some slightly other angles on the sextant and slightly other azimuths. They don't vary a lot, but if you want to do it more precisely, you could do it like this instead of just taking anything in between, because these figures are only valid for 658. And here you can also note the minutes before or after. It's just a little tip. So this is how far we've got. So we are ready to shoot now, actually, if we wanted. If it hadn't been so that we would like to use our star finder and check if we can correspond this to the star finder, and that's done in the next chapter of the exercise.